Hi there, guys. Grace here with another pre-calculus trigonometry question. And the question we have here is that we need to solve for the given right triangle here. And there's two values that were already given, which is the angle of 75 degrees, and we also have a side length of 110. Now, what the equation is asking us is we need to find the length of the side adjacent to the given angle, round that value to 2 decimal places. And then we also need to find the length of the hypotenuse, which we need to round that by 2 decimal places. And lastly, find the other acute angle. Now, there's several things going on here, but the main thing is we need to identify is that we do have to use some trigonometric identities. And the main thing is that we have to identify which identity we have to use in order to find these lengths that they're asking for. And so when we're trying to decipher this, we have to determine what our opposite, adjacent, and hypotenuse sides are going to be. And so let's go ahead and redraw that right triangle. And that way we can go ahead and label each part. And so the given sides that we see that we have a theta value of 75. We also have an opposite side value, and that's opposite of the theta value of 75, of 110. And so we now understand what opposite and theta is going to be. Now we have to figure out what they're asking for here, which they're asking for the length of the side adjacent. Now, the side adjacent value is going to be the side that's directly next to, on the right of the angle that we're trying to figure out. And so here we're going to go ahead and label as our variable x. Now let's go ahead and figure out what that side adjacent to the given angle is. And so essentially the trigonometric identity we're going to want to use is either tangent or cotangent, because that's how we're going to figure out what the adjacent side should be. And so I'm going to go ahead and use the tangent value, which since we're going to plug in for 75 here in our theta, and then we're going to go ahead and plug in our opposite value, which is 110, and then we need to solve for our adjacent, which we're deeming the value of x. Now, we need to solve for that variable x. And so when we do that, what we're looking at is 110 over tangent of 75 is what we're going to need to go ahead and plug into our calculator. And so when we get our calculator out here, let's go ahead and put 110 over the tangent of 75 and see what value we're given. And it looks like we're going to be given 29.47441117. And so, of course, they asked us to round that value to 2 decimal places. And so when we round that to 2 decimal places, our solution is going to be 29.47. And so that's going to be our answer for A. Now let's go ahead and figure out what our answer will be for B. And so in B, they're asking us for that length of the hypotenuse. And so when we go back and look at what we had before, we can understand that this is our opposite, this is our adjacent. The easiest way to know what our hypotenuse is going to be, whatever side opposite of our right angle will be given our hypotenuse value. And so let's give it a variable of y to just make things simpler. And so when we're trying to solve, we need to figure out which trigonometric identity is going to be best to use in order to solve and find that length hypotenuse. And so technically we could use sine, cosecant, cosine, or even secant in order to find this hypotenuse value. But I'm going to use sine just to keep it simple. And so sine of 75 equals, and we, of course, that opposite side, which was 110, and then our hypotenuse value, which we gave it a variable y. And so when we're solving for y, let's go ahead and plug in 110 sine of 75, which that's going to give us a value of, all right, let's see what that says, 110 over sine of 75, and that's going to equal 113.8803798, which again, we need to go ahead and round that by 2 decimal places. And so our value that we have here for our hypotenuse side on B is going to be 113.88. And so that will be our solution for B. And C, when we're trying to determine what the other acute angle is, this is a simple one to remember. When we solve for a right triangle, we have to recognize that the total area of a right triangle is 180. Now, 180 degrees. When we know this information, because we know that this is a right triangle, one side of our right triangle is going to automatically be 90 degrees because of that right angle variable right there. We also are given another side of the angle, which is 75 degrees. And so if we just go ahead and simply do a subtraction of 180 minus 90 minus 75, we'll be given a value of 15 degrees. And so that is our acute angle that we were given from the original problem. And so now we know that that acute angle is 15 degrees. Thank you very much.